Today's lecture is on the t-test. So we're going to start out by loading the library tidyverse and then our dataset affairs, do a quick summary. And today for the t-test, we're going to be comparing the mean of something between two groups. Our variable of interest in this whole study is faithfulness. So here we have the variable affairs, and it counts the number of affairs, number of months someone has had an affair during the past year. However, we would like to define, and it lends itself for the t-test, a new variable called cheater. Basically, yes or no. Are you cheating or not? And this really helps us, this really enables us to use the t-test. And the t-test is, quite frankly, more appropriate. Or let's just say also the variable cheater seems to be more appropriate in that basically either you've cheated or you haven't. So with that said, we create this new data set called cheater. It is based on the data set affairs. Then we create a new variable called cheater, which is basically affairs greater than 0. If affairs are greater than 0, we will assign a number 1, and if not, we will assign a number 0. 1 for cheaters, 0 for faithful. We know that because we've done the summary, we know that the variable affairs goes between 0 and 12, and there's no missing values. Therefore, if affairs are greater than 0, meaning that you've had an affair, we've labeled you as a cheater. If your number of affairs is not greater than 0, then it must be equal to 0. Therefore, we are labeling you as faithful. Let's check to see if this worked out okay. And it did. So the variable cheater is between 0 and 1. And look at the mean, 0.2496. We could have had this variable as a yes-no variable. However, I personally prefer to have dichotomous variables as ones and zeros because it lends itself for certain calculations, such as the mean, meaning that in this overall data set, 24.96% of the observations are cheaters. Okay, without further ado, let's run a t-test. So this t-test is this is the syntax, t.test, very similar to core.test. And the difference is this, and I'll explain to you why. So we take the variable age, and we want to compare the means of age by the variable cheater. In other words, calculate the mean age for cheaters and the mean age for non-cheaters. So again, it's important that this reads by. If we would have had put a comma, this test would be testing the mean of age. Is the mean of age different from the mean of cheater? Of course it's different. But it doesn't make much sense to do that test. Therefore, let's leave it like this. Run the test. And we have our p-value, which you probably, if you were looking along, had a guess what it was going to be. Our p-value came up to be 0.1413, which is greater than my chosen alpha of 0.05. Therefore, I will retain the null hypothesis, and I'm not going to say that these two groups, the ages between these two groups are different. Look at our 95% confidence interval. It goes from negative 2.8 to 0.41. That means that we are 95% confident that the difference between the two means, meaning the means age of group 0 and mean age for group 1, the difference, we subtract them, is somewhere between negative 2.86 and 0.41. However, between these two numbers is the number 0, so there is a probability that the mean age, the difference between the ages of these two groups is 0, meaning that they are not different. So we conclude that age has no effect on cheating. We could have just plowed through and say, just write this down and move on. Okay, we retained the null hypothesis, blah, blah, blah. But we should just ponder and think about this. If age has no effect on cheating, means that age cheaters, you can't say that, this older person must be a cheater. That's what people do when they get older. No, not what this says. Or perhaps, oh, these young people, they have no regard to the sanctity of matrimony. And you say, no, no, young people, there's no effect on age. There's no effect of cheating on age, or rather, cheating has no bearing. It has no regard with age. So, if we look at these means, these are the averages for each group. If we want to check that this is truly the average, we can just calculate it ourselves. So I ran the syntax, take the dataset cheater, then group by the variable cheater, summarize age, okay? I also took the liberty of summarizing rating. But so the age is 32.2 versus 33.4. 32.2 rounded and 33.4 rounded. Okay, does rating have an effect on cheating? In t-test terms, is the mean rating for cheaters different from the mean rating of non-cheaters? The alternative hypothesis, mean rating for cheaters not equal to mean rating of non-cheaters. Cheaters versus non-cheaters. Let's run this. And we see that the p-value is very small. We have our difference, we are 95% confidence that our difference is between two numbers that do not contain the value of 0. And the mean rating for people that do not cheat is 4.09, and the mean rating is 3.44 for the cheaters. We will conclude that the mean rating for cheater is different. You're saying, whoa, why do you, it's not different. It's the mean rating for cheaters is smaller. But no, our test just tested for, is it different? So that's what we're going to report on. Is different from the mean rating for non-cheaters. This due to the p-value is less than our chosen alpha. Fine. Now, you can't write your email to your boss saying, well, I've investigated rating, and rating between cheaters and non-cheaters is different. Well, the next question out of your boss is, well, who rates their marriage higher? Well, you can't conclude anything until you create a test, a one-tailed test, which the alternative is going to be greater. And so, because we already know that this group is bigger than this one, so and mean of 0 comes first, then the mean of 1. Okay, so let's do our test here. And our p-value is still significant. We have our mean, and basically we conclude that the difference between non-cheaters and cheaters is at least 0.46. Because it goes from 0.46 to infinity. That's a one-tailed test. Okay, now we can write our boss and say non-cheaters rate their marriage better. Okay, so same test. Let's talk about religiousness. So same test, but asking if the mean religiousness for non-cheaters is greater than the mean religiousness for, sorry, little typo. If mean religiousness non-cheater is greater than mean religiousness cheater. So this is making the hypothesis, the alternative hypothesis, saying that I believe that people that are religious are going to be less cheaters. Well, it's fine. You can say whatever you want. Just test it. So we've tested it, and it came out to be significant. And the mean difference in religiousness between non-cheaters and cheaters is at least 0.169. Okay? Now, some of you may say, well, what happens if I set it up wrong? Well, instead of greater, we can test less than. So in other words, or maybe you were assuming that people that were religious were more cheaters, so therefore, their religiousness, if people that were religiousness, their sorry, the mean religiousness for non-cheater is less than the mean religiousness of cheater. So you're thinking that again, it's different that you know cheaters are going to be less. I'm sorry, that non-cheaters are going to be less religious. Nope. So here we have a p-value that is way above 0.05. And again, we can't conclude anything here, so we'll just leave that one alone. Now, you may say, okay, how can I make this test with an alpha of 0.01? Here we go. Not a problem. So we're again testing rating by cheaters and non-cheaters. The p-value is still significant. The mean difference between of rating between cheaters and non-cheaters, I'm sorry, between non-cheaters and cheaters is at least 0.388. Okay? And if we just say, well, is that different from the previous one that we did? It is. Because when we're stricter, let's just run this again over here. Was this rating? Sorry. Rating, and here's rating. Okay, so when we're 95% sure, we say that the difference between the two groups is at least 0.46. But when we want to be 99% sure, which was this test, 99% sure, 99% confident, sorry, is at least 0.3888. It's still significant, and people that do not cheat rate their marriage higher. And that's it for t-test.